Alright, in this lab we're looking at projectile motion in two different directions, the x direction and the y direction. The fundamental principle that we're going to be using is Newton's second principle, which is V final equals V initial plus F net over m over delta t. Times delta t. Alright, this is the video that we're going to be looking at. Alright, first we had to set our calibration stick, which is 4 centimeters and 0.04 meters. That's the size of the wad of paper that we're using. Then we have our coordinate axis right here. The ball's going in the negative x direction and going up the positive y direction, then down because of gravity. Alright. Now let's look at the Python stuff. I use the same structure that we used in Lab 1, except now we have to look at the y direction as well, instead of just the x direction. So here are our initial velocities. We have g is 9.8, j hat's going into the positive y direction, and we set b to 0.06. Let's see, we run through this. Weight equals negative mg, drag force is negative b times the velocity, and the F net is the weight plus the drag force. Let's see, so let's run it. Alright, so let's run this. Alright, you see the movement of the ball. The top graph right here shows the movement in the y direction. The bottom graph shows the movement in the x direction. Now we have our data right here in the, let me get rid of these. Alright, we have our data right here in the Google spreadsheet, and our graphs look like this. This is the y graph, and this is the x graph. The reasons for the difference in the graphs are the drag force and the poor camera quality. So they're not perfect, but they line up pretty well. Alright, so what do we get from this? This means that the physics fundamental principles that we've gone over do a good job in predicting what will happen in an experiment, because these line up pretty well with low % error, so we know that the fundamental principles work. So yeah, that's it.